Så. Hvornår kører vi? Er det nu? Læg på. All right.
Thank you.
Thank you. Today, Jakob and I will present about a tool called the DLT, or Data Load Tool. And so we will show how to make a streamlined and cost-effective pipeline into Snowflake. Bit for the agenda?
Yes. A short introduction to Velliv and the current situation in Velliv, our platform. Some high-level thoughts about DLT Hub and the architecture that we will demo today. And then lastly, but not least of course, we'll try to do a live demo and hope that the demo guard is with us and the internet is working. Yes? Just briefly about us. My name is Jakob. I'm an architect in the Data and Analytics department in Velliv. I've been there for a little bit more than 3 years. Previously, I've been a consultant for 10 years in Inspire. Been working with data for plus 10 years.
Yes, and I'm Boris, and I'm working at Velliv Ejendom, which is a subsidiary to Velliv. And I'm a data and analytics manager there, and I've been working with data for about 4 years.
Very briefly about Velliv, if you don't know us, we are a Danish pension company. And even though that we are more than 100 years old, if we go back to when the company was originally founded, we are actually a quite young organization. In 2018, we became independent. Before that, we were Nordea Lund&Bendsen. That meant that we had to establish a whole new organization, whole new infrastructure on our own. And during that process, we decided to go fully cloud. So we're not cloud native, of course, but we are fully cloud. We have no servers on the ground. And we are located in AWS primarily, even though we also have things running, of course, in Azure and an old data warehouse in Google. Yes. So Ejvind has already showed this slide before. This was actually the one that he referred to. I have not created that, I must say. But the ambition with our new data platform, we say new because we are still on a Google platform, but we established a new platform on Snowflake for about 2 years ago. Originally, it was intended to be a platform only used by data analytics. We are a centralized team developing reports, but this evolved to kind of like a mesh-ish approach where we, instead of having one single domain within Snowflake, we actually have multiple domains for different business units. Where we can bring business people and IT people onto the platform so they are able to work with data on Snowflake, produce their own data products, all within their own domain. Some of these domains are, let's say, producers. So they produce data products. That would be us in data analytics, for example. Others are consumers that consume other data products provided by other domains, and some are both. So the idea here is really that each domain will have end-to-end or could have end-to-end responsibility for their entire data pipeline. From bringing in the data from the sources, modeling it on Snowflake, and exposing reports or data sets to applications and integrations to other tools as well. Zooming in on a domain could look like something like this. So basically, every domain gets their own area within Snowflake. And we provision all this using Terraform, just as was shown before actually. So whenever a new domain becomes online, we provision around 600 objects in Snowflake using Terraform. And everyone gets their own environments in Snowflake. They get their own project in dbt, their own project in Azure DevOps, their own S3 buckets, and so forth. So basically, it's all contained within the domain. However, because we are on Snowflake, it is possible for the data teams to, or the domains to share data between each other. We have a variety of different sources in Velliv. As any other financial institution, we have a rolling 5-year plan of getting out of mainframe. So we have a lot of flat files. We also have our core pension system, which is running on a SQL server. And we have multiple other relational databases running within Velliv network, Postgres, MySQL, so forth. Then, of course, we also have, we need external data from APIs. That could be CVR, all kinds of stuff, and other integrations. We're actually also utilizing Snowflake Marketplace or Snowflake private data sharing capabilities, getting data from SimCorp Dimension through Snowflake, but also public data sets that are shared through the marketplace, ESG data and so forth. So one of our issues is that being on AWS, and this is totally on my own opinion, AWS does not provide you out of the box with the best tools for ingesting data. They would probably point to DMS, to Glue, and to Lambda, but none of them really is a solution that works out of the box and something that we can hand over to our data teams for them to use themselves. Some of them have a lot of experience in coding, some of them has almost nothing. And like I said, we have a variety of different sources, so we need tools that can ingest relational data, fetch data from APIs, from flat files, and so forth. We have Lambda functions running to fetch data from APIs today. They have the limitation that they can only run for 15 minutes. Then we get a lot of flat files that is staged to S3 before they are loaded into Snowflake. And then we are working on a solution that will stream data from our core pension system into Snowflake, probably using Kinesis. And then we have Fivetran. And Fivetran is really, well, it's very low code. For those of you who doesn't know it, it's like point and click. And they have a lot of different connectors to relational databases, APIs, and so forth, and also a sync connector to Snowflake. So that's actually a pretty good tool for us. The downside of Fivetran is that it is very expensive, and it's consumption-based. So every time we bring in a new source using Fivetran, we really have to evaluate whether the value that we get from this integration is good enough for us to be able to pay for it as well. So we've been looking for another tool to kind of bridge the gap between Fivetran and the other different ways of ingesting data into the platform we have. And this is where DLT Hub comes into play. Oh.
And then what is DLT? So data load tool is a Python tool, which you can just pip install and then go. And it's very easy to use. You can run it anywhere where you can run Python. And so it can run in notebooks, it can run on backends, and it can run on Snowflake, which we will actually demo how to do that. And then it has automated maintenance, so schema inference. It will normalize data before loading, it will check the schema before loading, and it will also version the schema. So if there's a change, you can see that it will change the column and keep the history of what the previous column was. It's declarative, which means that I would say it's almost declarative, but it's Python, but you can configured much of it with the JSON, which I will also show in the demo. And then it's also fully customizable since it's code first. It's very easy to get going, but if you, I don't know how many of you work with Azure Data Factory. It's very easy to get going, but once you hit some very difficult level, you usually start with Azure Functions. So this is also something that could help with that part. Just a bit of the features. I mentioned some of them. So schema detection, seamless integration with a lot of sources, easy maintenance. It's also very easy to export the data that you work with locally before loading it to the data warehouse. And it's open source. They're working on a paid edition, just like another one we know, DBT. But so far, I haven't seen anything from them that it's still in preview. But the open source is production ready and very good to go. This is the code. This is how you connect to an API. And it's, about 20 lines of code, but much of it is JSON that you can work with. So this one will connect to a REST API and then load to a DocDB database. An example for how you connect to a MySQL server. This will copy the whole database to a local DocDB, but you can also do it to Snowflake or other verified sources. You can, of course, also run your own queries and all that, but this code here will dump the whole database. It's very easy, very simple to get going. A bit of the architecture that we will show for the demo. We will show how to ingest the data using Snowflake Snowpark. I'm not sure I would recommend to do it, but at least we wanted to make this very relevant for Snowflake. So we have this architecture that, would you say a little bit?
Yes, of course. Yeah, so like Boris said, it's you can run it everywhere where you can run Python. So in this example, we will actually run it within Snowpark in a container in Snowflake. And this is the different components that we will demo today. So we would have to push a Docker image locally from Boris' machine into the image registry in Snowflake. And from the image registry, the image is pulled to a container that runs within a compute pool in Snowflake. And since we are running a container that needs external access, actually fetching data from an external API, we also need to create an external access integration and apply some network rules that would actually allow the container to access the public internet. And then, of course, the DLT hub running in the container will connect to the API and store the data that it fetches from the API into a Snowflake database.
Any questions so far? Okay.
Can you run the database query in the same compute pool, or you need a warehouse for it?
It runs in the same compute pool.
So ingesting can do the. Can run sorry. The question was, can you run the warehouse or the database inserts on a virtual warehouse? Do you do that, or do you run it in the compute pool?
It's running in the compute pool.
Okay.
Yeah.
So since I work in Velliv, we are very focused on ESG. And one of the data sources that we work with is Energy Data Service. I will not show the table that we usually use because it's large and it will take too long for this demo. But it has a very simple API that you can connect to without any secrets or. So this is the data that we can get when we connect to the API from the browser. So if I had to write my own function to take all this data and put it in a database, I will start from scratch. That takes too long. So this is the source code for integrating with Energy Data Service and loading this into a given destination. So what we have over here is the basic setup for this project. We have a DLT folder, which has the config and a secrets file. The secret files contain secrets. So it's for local development, which you do not put into your GitHub. But you can use this file and you can upload it to wherever you We'll run the code, and then it can pull from there. Then we have the Docker file. It's very simple. It takes a base image Python and builds it, and then copies everything into the image. This is the code that we're using, and we are importing DLT. And then we define something called a DLT source, where we can, by a JSON file, say what we want to, how we want to process this. So if we look at the overall, we have 3 levels. We have the client, then we have resource defaults, and a resource is, for example, an endpoint. So every time I define a new endpoint, I will be able to say it should always do this on all of the resources. So in the client, we have a base URL, which is in the Git service at /dataset, and then I defined a paginator. It has different standard pagination rules. So, and if, of course, there's a special one, you can build your own. It's very easy to do. This one will offset by, they will use an offset pagination and then limit by 100,000. And it will go to the path to show the total, so how much it should paginate. Then the defaults, we have a write disposition. So this one is what I think is a very nice feature. When I say replace here, it will truncate and load. I can also write merge. Then it will delete and insert if I define a primary key. So it will keep the newest version. I can also write, let's go back to, I can also write that it should do a slowly changing dimension. And then it will just fix it. It has all that functionality in it. So then for, how do you connect to an endpoint? So this one is capacity per municipality. If I just write that in resource as this, then it will connect to that endpoint and load the data with a replace. I can also easily set up incremental loading. So this is an example for another endpoint where I want to load the data incrementally. Here I define the name of the data, the endpoint, and it will automatically convert this to Snowflake friendly underscore naming convention. So this will be powers underscore supplier, blah, blah, blah. Then we have the path. That's the actual URL. So that's the same as we see up here. And then this is the incremental for this one. So this will load into the URL, which will say start, and then the value that is your start. And in this case, the start value will be 2013. And the next one, the next load, it will check and see when was it run the last time, and then it will start from there. The data selector is to show if the data has some metadata that you don't want in your data set. Then you will just right here, it has a record. So if we go back to this one, we can see that the data is in the actual records, not this metadata, which I don't want. So this will be the only data that we will see. And the write disposition for this endpoint is merge. So it will overwrite the resource default. So it's only for this endpoint. Let's see how much time we have. OK. Then this is how you actually run the pipeline. We have a pipeline name. We have a destination, Snowflake. We have a data set name, that's the schema name. And then we can show the log. I could also, if I wanted to see the data first locally, I could write DocDB. It will automatically load the data into a DocDB database, which runs locally. And then I can export the data with the Streamlined or with my own SQL client before using Snowflake, because maybe the credits are a bit too expensive. I don't know. Then we have the pipeline run, which will run the service. And then we also have some tracing that, but 60 lines of code, much of it is pretty much configuration. All right. Then let's see here. So we have a clean setup, I think. Let's see here. usually with the internet. Let's try again. Okay. So to run this, we will create a compute pool. We will create an image repository. We will build the Docker image. We will upload the image or push it to the repository. And then we'll run the code on a Snowpark container. So as you can see, it's a totally clean environment. I don't think I have time to explain everything here, but it's overall what we do. So
It's basically just creating the resources
Yeah.
in Snowflake, right? So we are creating a database, we are creating a schema,
exactly.
the compute pool.
So the thing is, if you run it on Snowpark, you can actually access the internal Snowflake. We have not been able to do that prior to this presentation, but I think it will make this a lot easier. So we had to whitelist our own Snowflake account because it goes through the external internet. But I think it's very possible to access it through a session. I'm not sure how to do it in DLT, but again, if you spend if you use a bit time to research, I think it would probably be quite easy. So now we have everything set up. Let's see here. We have the database, we have the schema, and then we will take this folder, and then we have some bash code. So this will take the repo, zip it, upload it. You could also, of course, set up a CI/CD pipeline for this. So if we go here and copy in this code, it will upload it to a VM because I'm not allowed to have Docker on my own PC. So I have a VM where I can use it. And here we unzip it, we go in, then we build it, we log in, and it's okay that you see the password. We'll delete everything afterwards, so it's no problem. Any questions while we are, I hope?
A lot of the things that you're showing, Boris, I assume that you only need to do once. So could you highlight what are the things that you're changing on a daily basis and what is something you're doing, not that frequently? Is it only the VS Code, the DLT that you're changing, and then all this normally in the static?
It's basically when you want to set up a new source, right?
Okay, then you need all this configuration as well, or can you reuse the same?
You can reuse the same. So this is just the initial configuration in order to get this working. Right?
Yeah.
Understood. Okay.
And this, so here if I wanted, this is, if you did this once, then it's only the execute job service command here that you have to rerun or re-upload if you change the code. And of course, if you want a new endpoint, it's very easy to add. So here I could just write in a name on a new endpoint. So I have if there was an endpoint called production per unit, I would have added it now. So it's very easy to, on the same source, add new endpoints. Okay, so let's try and see if this works. So this will run for about 1 minute. And what we've done is that we execute the job using the compute pool. And this is the specification, which you can also have in a repository. So we defined it in the code here, but you can also have in a repository and load the specs from there. And all it says is it takes a container that's called echo from this image that we created. And then we use the external access integrations to run it. And the thing is, if you use it in Snowflake, you have to build your own monitoring and you have to build your own alerts. You can do that easily with the logs, but it's just an extra thing to consider if you use this. But they say that this is not production, it doesn't live up to the SLA, the service level agreements. So you should think about if you wanted to use compute pools or execute job service. this one, execute job service. It's not in part of the service level agreement yet, but I think it will be at some point.
How do we handle secrets?
Sorry?
How do we handle secrets?
So secrets are handled in this one, this file.
Yeah, I know, but how are you handling that?
So this, in this particular case, I am just copying the secrets to the zip file, which I have in the image.
Okay, so
But you can ping if you have, I don't know, if you're using Azure, you're probably using Key Vault.
Yeah.
You could ping that. So
All
it's,
secrets in Snowflake. They have their own secret vault as well.
yeah, you can also use that if you want. So this looked like it worked. So here we can see that it's doing a lot. I won't go through the whole logs, but this part is saying it's normalized complete. So it's loading something to the state, which is a helper table. And then we can see that it's loaded 10,000 rows and 7,800 rows, or it's normalizing. Then we can see that it took 18 seconds, and the whole run was 22 seconds. Over here, we have new data sets. We have Energi Data Service, which was the name that I had on the data set. We have the 2 endpoints that I had. And we also have something called staging. That was because I defined merge. So when I use a merge, it will create a staging schema, which will then do whatever I told it to do to the original schema. So it will always, if I do a replace, it won't create this part. So you can see it's only one of the tables here. Somebody's calling. If I rerun this, it will only load, because I said it should be incremental, it will only load one of the tables. I don't think we have time to show it. But basically, it will not load the rest of the data on the merge part. And then when we're done, clean up. Shift 5, I think. Just to show some, it's their own, from their webpage, so I haven't verified this, but this is some of the benchmarks on Airbyte, Fivetran, Stitch, and DLT. So again, DLT, they run this on the Google Cloud Run. So they ran 25 million rows, or about 6.5 gigabytes in 4 minutes. If you wanted to do that in Fivetran, it would be $4,000 per month. This will be free, but of course you have to manage your own infrastructure. You have to do a bit more, but I think it's a good middle way to use it. But then again, as Jakob said, some sources are very important and critical, and it's easy to use Fivetran. Go ahead. Yeah. Others, if it's a quick and dirty, I would recommend looking into DLT. It's quick to use and very easy to deploy. You can, I mean, if you can run it in a DevOps pipeline. It's very, very good to use. Questions? For? Oh.
So I'm not seeing anything obvious about state between runs. Seems like something about files and reading that. Is there a nicer way to carry like a shared state for given pipeline or endpoint or something, so that you're not rerunning every time, but can actually pick up from where you left, or have daily runs or something?
So they have state managed. You have to set it up, but they have these helper tables that you can use, and they can save state there, but they don't recommend to use it if it's very large data. But you can, if that's your question, you can at least use it to say, okay, so this was the last time it ran, and this. So it has that possibility, but it requires a bit more setup.
And it seems like it needs to run fairly close to the program, or in like files or external tables is an option as well to run it in a Postgres database or something. Basically, can I separate the state for a given pipeline run from the
Yes.
pipeline code and run and so on?
So the state is saved on the destination that you use.
Ah, okay.
So if you use a different destination, it will save the state there. So I recommend, when I've worked with it, I use a one pipeline, one file per pipeline, and then I can have different destinations there. Yeah. Okay. Thank you.
Yes, okay.
Ja, kan du høre mig?
Ja.
Kan du også høre mig?
Det kan jeg, ja.
Perfekt. Sidder den godt der?